Hi Alex, and let's break down animations. So let's start with a splash, and I'll have to talk a bit more about physics and the principles of splashes. So first off, I actually pretty much enjoyed the design. I think this one frame in particular is pretty nice in terms of contrast tonality and a nice silhouette. So overall, I think it's pretty cool. So the thing that we can push here is the first and the second half, mostly the second half of the animation when it starts going down. And then we should keep in mind how splashes work. So let's talk a bit about splash physics. So when the splash happens, let's pick the best one. I think this one is straight the point the best so far. So when the splash happens, what happens first is we get to see fast rising shapes. And this is a medium-sized splash, so the shapes are a bit more foamy rather than clean and clear. Then the splash expands and we can have a lot of variety in shape because this is a fast transition, so we can quickly change the shaping. In this case, you can see that we go from this to this as it's changing and expanding in space. What happens later is a splash expanding both at the bottom on the sides, and these parts can break up and go up. And then we go further, the flat splash starts going down at the bottom, but the top parts, the particles at the top, they're still going up. So if we take this and define the edge, we get this kind of thing. So the bottom is going down, but the top, not yet. It's still going, it still has the energy, it still has the flow. And if we really look at it, it will look like this. So the bottom, by this point, has already fallen down, while the top is just starting to fall. So the path for the bottom part, the path for the top part. If we track particles specifically, they will all go in sort of a curve that we had for bouncing balls. So for example, this particle, it can go in a spacing like this, going back in space. This particle, well, this one can go in a curve like this. So imagine that we are starting here, going 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 here. So that's the path for this particle, for example. And for this particle, it has a bit smaller amount of energy, a bit less energy, so it will fall a bit faster compared to the top one. And it works usually like this. So the top particles are the particles that have the most energy. So they were created when the splash was created. So they had the most amount of force influence them, and they go the highest. And because they go the highest, they also slow down at the top, but they will take more time to fall down, at least because they go in so high, and they need more time to cover this distance, but also because they had more energy to begin with. The lower we go, the faster things fall. So this scene will probably fall later than this scene. This scene will fall later than this scene. This scene will fall later than this scene. This scene will fall later than this scene. And this scene will fall later than this scene, which is understandable. And so we can create a chain reaction of scenes falling faster and slower than each other. And we can observe it pretty much in all the cases. So you can see it here, for example. Here we have a very flat splash, tiny splash. So, for example, here, this particle right here, well, not that I can actually catch it on the next frame, but we can catch these particles. So you see they're going up, slowing down, and then they should be going down. 1, 2, 3. You see this one has a bit more speed. And it's slowing down, and it's going down. And it's going down. And then it's going down. It's going down. It's going down. While at the same time, this part of the splash is already slowing down and going down. And you can see that it can go down and still keep breaking up into particles and leave particle trails. So that it can still leave particles with a bit more energy that fall just a bit later. And again, it's still the curve. So right here, it's the curve in space, like this. It's the curve in space like this, it's the curve in space like this, a curve in space like this, a curve in space like this. And all of them are going along this curve of energy. And we can imagine it as like the water being funneled out from the center, expanding to the sides a bit, and going to the camera, away from the camera. Stuff like this. So now if we look here, so what's there and what are we missing? So we have some nice breakup, we have some nice ideas for design. So what we are missing is particles going with a delay, and we're missing some of the curvature. So if you look here, there are some scenes where we miss the curve, or we don't have a delay between the particle and the main mass. So let's look here, for example. Okay. So we go, this particle goes, and then you see we quickly switch to the left, and immediately we start falling down. And all of that area falls with roughly the same spacing. So if you look here, we get a straight lines. We get a number of parallel straight lines. We get a number of parallel straight lines. And if we look here, we kind of have curves. And if we look here, we also will see these curves. And the further we go, the more apparent they will get, because the top particles are being funneled out while the bottom has already fallen down. So it's usually, so it can go to the side more. It can go more straight, but we just need to understand why is it created. And it's created because every cent doesn't fall at the same time, and we have a delay. So this part will fall faster than this part, and this part will fall faster than this part. So how do we manage that? So let's see. So let's keep these two frames. Okay, we're keeping this. And when we are creating these particles, we can push the movement further. So for example, let's say we have something like this on this frame. And again, we need to keep in mind that it's also expanding on the sides. So you see it expands on the side and suddenly it doesn't. So essentially what we can do is we can give a guide to ourselves. A guide of how splash is spreading out, just general guide for where our center can be. And I'll hide it. Okay. So 1, 2, 3, and we're going off the guide. We need to have more of that. Maybe push it a bit more. Okay, so if it's within the circle, okay, so we have this. I'll change it this part a bit. And we see that this part doesn't change. So 1, 2, okay, we need to expand this further. Okay, for example, we have this. Okay, next frame, what do we need to do? We need to keep pushing the energy forward. We need to keep expanding it a bit. We need to keep these particles moving. So how will these particles move? I mean, we kind of established that already with the frames that we have. So let's look at this particle here. So right now, it goes 1, 2, okay. So it should continue moving. It should lose energy on the way, slow down, and it can go down and accelerate. Okay, this particle has a bit less energy, so we can slow down more, faster. This particle has the most energy so far, so we can move it even further, move it even further. This particle height right here, so it can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so far going down. So this is our path for the particles, and we can have this one as well. So we go, we slow down, slow down, slow down, go down, go down, go down, go down. Okay, so all of them define curves directed in different direction. Oh, bro, okay. And they kind of help us define the space the splash takes place into. Of course, this is just a guide, and we don't have to follow it precisely. It's just a reminder of how the things work and how to think about it. Eventually, you don't really need the guide. You just keep this in mind and go. Okay, okay, and now we have this house breaking up the scene. Okay, and this edge starts slowing down, slowing down. And I would suggest, if this is a back edge, it can go like this. If this is a front edge, it would be better to move it to the right since we're expanding from the center. And this makes it feel like it's going into the center, which can happen if it's the back side of the splash. But if it's the front side of the splash, it feels a bit weird to move it to the side here. We can solve it by having it more to the left here. Okay. So we're going. Oh, the delay table will help when I don't see anything, but okay. Can break up the particle here if we want. Create connection here. Let this thing rise. Let this thing rise. Start creating more hooves here. Don't forget about moving this edge as well. It shouldn't be static. Okay, so we've reached this point. Now what happens here? So we're falling down from this point on. The particles at the top still going. The top part of the splash can still going. It can still go a bit. And the bottom of the splash starts falling down. So the particles can keep going. And we can keep breaking up particles when we need them. Now, if we're doing more realistic splash, it will expand on the sides and kind of fan out, spread out, break down into particles and stuff. More stylized splashes can also fall more straight down. This is also a possibility. And now I'll go into no comment mode because I actually need to concentrate a bit. Make this deceleration at the end more gradual. And now we'll start the acceleration on the way down. I'll use this curve. We need to delay this edge because it's higher than the other one. So we can erase, but it shouldn't immediately go down with all the particles. Okay, now we need to make it more interesting. We can expand some of the O's faster than the others. Definitely far from the best design-wise, but we'll make do with this. Get the overall shape has to keep going still, at least at the top, to continue the motion. Okay, and we have a couple frames left. Definitely far from being a good design, but I hope the principle is clear. Yep, definitely not the best design. So we have faster deceleration at the bottom. It doesn't go as high, and we have a shape change. And then when uh, we go down in the order of particles and things appearing. I did make it a bit too fast here. A bit too slow now, but hopefully that's pretty clear. And for this kind of animation, the most important frames are to plan the middle frame, so how it looks in the middle, how it looks near the end, and how it looks at the very end. Because then you can keep the design in mind, unlike me doing it here, just trying to fit it to the existing scene and think about the motion first. Acceleration. Cursor structure. Enough of this, enough of this. Okay. This one, actually, I think it's working pretty well. I think generally the speed is there, the timing is there. The only thing is that I think in the middle, as you said, it seems to be going to the side a bit too much, like a lot. And because of that, it may be a bit jarring, just because the main direction is to the side. So we're slowing down, and then we have this acceleration to the side without actually moving there afterwards. So we're going up, slowing down, we're going to the side a lot, slowing down, accelerating and slowing down again. And then we're going down almost in a straight line. And so if we imagine it, and if we imagine the curve, I think what we're missing is a slowdown, because right now it seems like it jumps to the side where it shouldn't jump as much, right here. And if we imagine it as like a ball going, so you see this, the direction, the motion to the side will be noticeable between these frames and between these frames. Uh, and what we're noticing is that instead what we're getting is we're getting one, we're getting two, and all these frames are very close together, and there's only one frame that pushes it to the side. And that's why I think it's a bit off. So we're kind of, okay, so we're jumping to the side, to the left, and then we're immediately going straight down. And so I think if we look at the reference, it's a bit more clear in that regard. Let me find it. So we're going, we're going, we're going. Let's define this map. So we're going, we're going, we're going, we're going, we're going. Okay. I think it's the same issue in the example. Kinda has the same kind of feel. The only thing that's different here is that the motion is a bit more consistent. And we kind of spin it back. And if we look here, we're going. I see, I see. I see. See that what you see right here, there is no slowdown. And then there is an immediate slowdown. And then we're stopping in one spot. Stopping at one spot. And then we're going down. So despite the fact that the motion to the left is more or less the same in all of them, having that slow down, and then we're going down helps us a bit to solve that issue. I think the second thing could be the motion of secondary particles. Let's see. One, two, three, one, two, three. So you see this particle is going at an angle, but it's pointing straight down. So if the particle is going here, it would be better to angle it like this. Angle it to the direction of the motion. This particle is angled down because it's going straight down. This particle is angled down because it's going straight down. But it doesn't make much sense when the particle is going diagonally and it's angled straight down. And personally, I would move this a bit higher up here. So we're going, and it feels like we still have energy. So we can have it go up a bit more, tiny bit more. Then break down, then start going. But aside from that, I think you're pretty safe and it's looking good, generally. Of course, there are some small things that you can push and vary. Like I think this bottom particle here is going up for a bit too long, to the point where it falls almost later than the first particle that was created. And we can push the fall down on this particle as well. Think we can let it start falling after this frame. So one frame earlier. And this particle can have even less energy because it's even lower. So it can start falling even earlier. So we can have even less energy here, even less energy here. Almost start falling here, here, and fall down. Because right now I think we're like in a bit of acceleration here on these two frames. That's it. Hope it helps you.